Our topic for today is constituents of the atom. Constituents of the atom. And when we are talking about atom, in our previous class, we've looked at atom, that atom is what? Is the smallest particle of an element. So when we are talking about constituent of an atom, so we are talking about what we can find in an atom. And from what we have learned before, see, atom, this is an atom, and then in an atom you see you have a shell, and this is a shell, and on that shell we have three particles. We have a particle called electron, and inside the atom we have nucleus. What are the particles you can find in the nucleus? There are two. We have proton, and then we have neutron. So these three particles are talking about electron, proton, and neutron. They are three particles of an atom. And these three particles are what we can find in an atom. That's what we refer to as what? Constituent of an atom. So according to Rutherford, so it was one that proposed that anytime you have an atom, there is always a shell where we can find electron, and inside the shell nucleus we have proton and neutron. Okay, we want to look at, and from here we can talk about atom. Let's look at it. We can say atom generally consists of proton. So an atom are made of positively charged nucleus. If I say positively charged nucleus, it means that is positive proton and neutron that has no charge. Because nucleus is made up of positive charged proton and neutron that has no charge, we can say atom is made up of positively charged nucleus. So apart from that, electron is found. You can see electron is found on the orbit or shell. On orbit or shell of an atom. Surrounded the nucleus. Surrounding the nucleus. So we can see surrounding the nucleus, and this one will now take us, let us put it in a tabular form. Let's look at the properties of this nucleus. Here we can have a particle. In the tabular form we have particles. Here we have mass, and here we have charge. What to talk about in summary? I want to summarize the properties of what? Of three particles of an atom. So let's take the first one, which is what? Electron. You can see what is the mass of electron is 1/1840 of what? Of mass of units. So of mass of proton. and its charge is negative. You have a negative charge. Then you have proton. A proton has 1 unit of 1, that is, just in form of 1 unit. And the proton, this charge is positive. You have a positive charge. And the last one there is a neutron. Neutron have the same mass as the mass of proton, also of half unit of 1. But what? In charge here, it has no charge. Because of that, one can say neutral. We have a neutral charge. That is, that doesn't have any charge. It's neither proton nor neutron. So because of this, apart from this, we can say generally that atom is electrically neutral. We are saying atom is electrically neutral means that is number of a proton is the same as number of neutron, as number of electron. So let's say, for example, now you have sodium. For instance, you have sodium. If you look at this sodium here is 1123. For you look at sodium, you have atomic number of 11. It means that you have a proton number of 11. At the same time, electron 11. So that means you have a plus 11. And electron, which is 11, also have minus 11. And when you have the two together, so the positive and negative there will balance each other. That's how we call it what? Electrically neutral. That is, total number of positive is equal to total number of negative. By the time you add it or they react together, give us 0. So therefore, anytime you have an element or an atom, always have the same number of proton and the same number of electron. So that is what we can say about atom. So this one will now take us to Dalton atomic theory. Dalton atomic theory. So let's read what Dalton is telling us about an atom. He proposed, though he's a father of we're talking about atomic. So Dalton, generally we have certain theory about Dalton. We have Dalton atomic theory. Dalton atomic theory. Here we have Dalton proposed that all matter are made up of a tiny particle. All matter are made up of a tiny particle. Called atom. That is what the Dalton atomic theory is saying, that anytime you see a substance called matter, they must have a tiny particle inside them, referred to as what? As atom. Irrespective of the state of that matter, they must have an atom. Also propose that too, atom can neither, we also propose that atom can neither be created nor destroyed. So he proposed this, although some recent happening have negated this, like radiation. Some atoms can be destroyed. But initially when he made this law, he said atoms can neither be created nor destroyed. So then another one propose the atom of the same element have the same atom of the same element. The same element have have the same atom of the same element have the same properties. Have the same properties and the same mass and the same mass. Let's look at this. If you look at sodium and then let's look at aluminium, you can see they are atoms of different elements. So the way sodium will behave is different from the way aluminium will behave. If you have sodium and another sodium, so this sodium and this sodium, anywhere they find themselves, they have the same properties. That is, yeah, physical properties and chemical properties. But here now, sodium and aluminium, they are different. For now, we can say sodium can what? They are soluble in water, even in cold water. But aluminium, they are not soluble in cold water. That's what they're talking about. Atoms of different elements don't behave the same. But if they have the same element, they behave the same. Likewise, they have the same properties, whether chemical properties or physical properties. Another one is atom. When atoms combine with each other. When atoms combine with each other, they do so in a simple whole number ratio. The simple whole number ratio. What this one means is that, let's say for example, I want to write water. If I want to write water in chemistry now, I write H2O. So that means that there's a particular ratio in which what an element can combine in a chemical compound. I can write water as H4O. I cannot write H4O as water. I mean, there is a particular ratio, there is a particular certain number of atoms in which what two or more atoms will react together to form a compound. That is what it's saying. For example, now for water, we always say that what it's a ratio 2:1. That is, two atoms of hydrogen always combine with one atom of oxygen to form water. Likewise, ammonia. If you want to write ammonia, you say okay, NH3. It means anytime you want to write ammonia, 3 atoms of hydrogen must combine with one atom. There is a certain ratio in which what a number of atoms come together in a compound. So that is atomic theory. So that's in atomic theory. So this one has to take